how to use this Six Sigma matrix in internal quality control in laboratory. So first of all, let us see why it is necessary to use Six Sigma matrix in clinical laboratory. Because most of the laboratories design the QC protocol as per the accreditation guidelines or as per the workload. As per the good laboratory practices, customized individualized quality control plan is recommended, and this customized quality control plan should be based on Six Sigma matrix analysis. The incorporation of Six Sigma matrix results in the reduction of laboratory errors by maintaining 6 standard deviation between the parameter average and its upper and lower limits. Statistical quality control is an essential lab practice to ensure reported results achieve the quality required for intended medical use. Modern highly automated systems provide many function checks to ensure proper operations. To produce accurate results, no analytical system is perfectly stable. So laboratory needs statistical quality control to provide a final independent check to detect performance changes potentially and causing medically important error. So as we have seen, the Six Sigma concept is basically taken from manufacturing industries. Modern laboratories are also comparable to the manufacturing units where thousands and thousands of results are generated per day. So basically medical laboratories are also manufacturing thousands and thousands of reports per day. So it is to maintain quality, the error should be reduced or the defects should be reduced. Here the reducing the errors or reducing the defects means making the reports more precise and accurate. This can be done by implementing Six Sigma strategy in medical laboratory. But if we see the recommendations of International Federation of Clinical Chemistry and Laboratory Medicine Working Group on HbA1c, they also recommend the standardization of methods in laboratory for HbA1c should be done based on Six Sigma matrix assessment and judge the quality of the method using the Six Sigma matrices. To understand the analytical method performance on Sigma matrices scale, there are no comparative values against which these results can be judged. So instead we use the data which is already collected using imprecision and which is expressed as CV percentage, and we also use trueness that is expressed as bias. So this data is routinely used to calculate through the use of internal quality control. Now how it will be done, let us see here this diagram. Here the true value that represents the patient's real clinical status in the center. But as we run the test of the patient sample, we never get the results to be exactly the same what that take in the form of normalized distribution around the values instead. And here you can see the total allowable error on both the side of the mean distributed up to 6 standard deviation, which is a total allowable error. Now if we squeeze the 6 standard deviation of our analytical method distribution within this total allowable error, in the absence of bias, we will be able to achieve the Six Sigma goal, and which will be expect to generate fewer clinical defects. So if you see this normal Gaussian distribution curve, here if we see the 3 Six Sigma is up to 3 SD, we can find out the variation up to 99.73. If we expand the tolerance limit up to 6 sigma, that is up to total allowable error up to 6 sigma, the percentage yield of the process will be 99.9997%. So here the defects which can be pointed out will be 3.4 defects per million. By increasing the Six Sigma level from 3 sigma to 6 sigma, or by increasing or expanding the standard deviation from 3 standard deviation to 6 standard deviation, accuracy of finding out the defects will be up to 99.9997%. So this is how we can use the Six Sigma matrix for finding out the defect and correction of those defects using the Six Sigma matrix. So let us see in our next video how to calculate this Six Sigma matrix in internal quality control using the data which is already available in the laboratory. Till then, keep following and thank you.